Okay, we're looking at the 10.2C practice quiz today. The situation in this quiz says that acid rain is a serious problem in Canada. In many cases, lakes become so acidified that they cannot support any significant fish life. One possible and very costly solution is to try to mitigate the effects by dumping crushed limestone into the lakes. This will neutralize the acidity. The following is actual data from a study of such an intervention. From enormous samples at other control lakes, it is reasonable to assume that under the acidic conditions, the weight of individual fish of a particular age class is normally distributed with a known mean of 3,015 grams and a known standard deviation of 392 grams. 1 year after the addition of limestone, a sample of 22 fish was taken partway through the study and the weight of the individual fish was obtained. Here is the sorted data in grams, and then you can see there's different weights for 22 different fish. Notice that several fish had abnormally low weights, below 2,000 grams. After further investigation, it was discovered that these fish had ingested pieces of plastic from a litter bug's styrofoam cup and could not properly digest food. Question 1. Compute the interval mu plus or minus 2 sigma for the fish reared under the acidic conditions. What does this interval mean? So the acidic conditions would be the original situation before they added the limestone, and in those cases, we know the mean was 3,015 and the standard deviation was 392. So just plugging that data in, we get the interval 2231 grams to 3799 grams. The concept for what this means, because they asked about 2 sigma and that they mentioned originally that the data under these conditions was normally distributed for other control lakes, is that you need to use the empirical rule, which is the 68, 95, 99.7 rule that we learned at the beginning of the course. And specifically the middle number 95, that means that that's the amount of data that's within 2 standard deviations on either side of the mean. So when they ask what does this interval mean, we need to say that we're 95% confident that the true population mean fish weight is contained in the interval that we've computed over here. For question 2, it says the study's method of analysis was to delete all values less than 2,000 grams. The values of X bar and S after deleting such values are 3407.6 grams for X bar and 370 grams for the sample standard deviation. Construct and interpret a 95% confidence interval for the mean weight of the fish after the lake is treated with limestone. Do not assume that the value of sigma equals 392 grams from the lake prior to treatment is applicable to the new fish. What do you conclude about the effectiveness of the treatment? So, because we're doing a confidence interval, we need to follow the 4-step process. The first step being parameter, second being conditions, third being calculations, and fourth being the interpretation. Our parameter in this problem is we are trying to find the mean weight, mu, of the fish in the lake after being treated with limestone. Our conditions, normally we've so far only listed the 3 conditions, which are SRS, normality, and independence, and checked to see if they were met. But now that we know that there's multiple kinds of tests or intervals that we could run, because in 10.1 we learned about z-intervals, where we knew the mean and we knew the standard deviation for the population, and now in 10.2 we're doing problems where we don't know the population mean or the population standard deviation. You need to list the kind of test you're going to do. So first off, I'm going to say, because I don't know sigma, I don't know the population standard deviation, because that's unknown, we're going to conduct a 1 sample t interval. And you always do the t interval when you don't know sigma. So our 3 conditions are SRS, and that wasn't stated anywhere in the problem originally. There's nothing up here that says it's a simple random sample, these 22 fish. But we need to assume that it's going to be, otherwise we can't do the problem. The normality condition, again, the 22 fish aren't stated as being a normal sample. However, if you look at a box plot of the data for this situation, you won't see any outliers and you won't see any major skewness. So if we take a look at the box plot real quick, I pulled up my graphing calculator on here. To put the data in for the 19 fish, you're going to go to Stat and then Edit. You can see I've put all the data in. To look at the box plot, we're going to go second mode, go back to the main screen, then go to second y equals. We're going to look at our stat plots. We're going to go to the first plot. We want to make sure it's on. We want to look at our graph type would be a box plot that would have outliers if they're present. That's this one. This is the box plot that hides the outliers if they're there, so you want to make sure you are on the box plot that shows outliers if they exist. Your X list would be list 1, so second 1. And then we're going to go to zoom 9, which is our stat plot. And you can see from this box plot that it's a little bit longer on the left side, so it's slightly skewed to the left, but there's no outliers. There's no dots after the whiskers of the box plot, so there's no outliers on here. So if we go back over here, we can assume the normality because there's no outliers in the box plot. The third condition, independence, again, that's not stated, but we need to assume that the different fish in the lake are independent of each other. So essentially, we're assuming a lot of stuff here, so we're going to be proceeding with caution. For step 3, the calculations, your formula for doing a t-interval is x bar plus or minus t star times s over the square root of n. And we need to also make sure we know the degrees of freedom, which is always n minus 1. There's 19 fish in our sample because we took 3 of them out for being underweight. So our degrees of freedom is 18. Because of this number 18, and because of the confidence level of 95%, if you go look at table C, you'll get a t-star value of 2.101. So then plugging the numbers that we know into this formula, x bar was given, that's 3407.6 plus or minus the t-star value that we looked up. The s, 370, that was given in the problem. Square root of n, which is the square root of 19, that was essentially given in the problem. You dump that information in your calculator and you'll get the interval 3229.259 to 3585.941. Step 4, the interpretation. You are 95% confident that the true population mean weight of fish in the limestone treated lake lies between 3229.259 grams and 3585.941 grams. Also, they asked, what do we conclude about the effectiveness of the treatment? If we are 95% confident that the true population mean weight lies in this interval, and the original mean weight was 3015, then conceptually our average weight now is higher than the weight of the fish in the acidic lake, and so the limestone has helped reduce the acidity and help the fish be able to grow larger because they're no longer affected by the acidic conditions in the lake.